Hey there, Angular developers. Are you ready to unlock the power of Angular lifecycle hooks and take full control of your components? You are in the right place. In this tutorial, we are going to dive deep into the world of Angular lifecycle hooks. I will show you exactly how you can leverage lifecycle hooks and efficiently manage their behavior at key points during their lifecycle. But before we jump into the details, let's take a step back. Why is understanding lifecycle hooks so important in the first place? Well, lifecycle hooks give you ability to tap into and execute custom logic at specific stages in a component's existence, from initialization to destruction. By strategically implementing the right lifecycle hooks, you can fine-tune your component's behavior, optimize performance, and create a smoother user experience. Simply put, lifecycle hooks are an essential tool for building robust, efficient Angular applications that can handle anything thrown their way. So whether you are a beginner just starting out with Angular or seasoned pro looking to level up your skills, this tutorial has something for you. I will walk you through the different lifecycle hook interfaces, show you real example of how to use them, and share some best practices and common gotchas to watch out for. By the end of this video, you will have a solid grasp on the component lifecycle. Now, how to wield lifecycle hooks to your advantage and be well on your way to creating more flexible, high-performing Angular apps. So what are you waiting for? Let's jump in and start harnessing the power of Angular lifecycle hooks together. Trust me, your components will thank you. Now that you are excited to learn about Angular lifecycle hooks, let's start by making sure we have a solid foundation. To really understand lifecycle hooks, we first need to talk about the component lifecycle in Angular. You see, every Angular component goes through a series of key stages from the time it's created to when it's ultimately destroyed. This is referred to as the component lifecycle. Think of it like the life story of a component, from birth to death and everything in between. There are several critical stages in the lifecycle, such as initialization, when component is first created; change detection, when Angular checks for changes to component's data; content and view initialization and checking; destruction, when the component is removed and cleanup occurs. It's crucial to understand this lifecycle because you will often want to tap into these stages and perform certain actions or logic at specific points. And that's exactly where lifecycle hooks come into play. Angular provides a set of lifecycle hook interfaces that allow you to hook into the various stages of the component's life. By implementing these interfaces, you can execute custom code at right time. So here is a quick look at the lifecycle hook interfaces available. Each of these interfaces has a corresponding method that you can implement in your component class. Angular will then call these methods at the appropriate time during the lifecycle. For example, the onInit interface has an ngOnInit method. If you implement this method in your component, Angular will call it shortly after the component is created and initialized. So why is this important? By strategically using lifecycle hooks, you can initialize data or properties, set up subscriptions or event listeners, access view or content elements, perform custom change detection, clean up resources when the component is destroyed, and so much more. Lifecycle hooks give you fine-grained control over your component's behavior and allow you to optimize performance, reduce memory leaks, and create a smoother user experience. It's worth noting that the lifecycle hooks we are discussing are part of the latest Angular versions, including Angular 17. So you can feel confident using them in your projects. Next, we will dive deeper into each specific lifecycle hook, explore some practical examples, and see them in action. So get ready to become a lifecycle hook pro. Let's dive into our first specific lifecycle hook, ngOnChanges. This hook is all about detecting and responding to changes in your component's input properties. So imagine you have a component that receives data from a parent component through input properties. Whenever these input properties change, you might want to perform some actions or logic in response. So that's where ngOnChanges come in. The ngOnChanges method is called by Angular whenever an input property of the component changes. It receives an object called simple changes that contains the current and previous values of the changed properties. So let me show you a quick example of how you can implement ngOnChanges in your component. So let's close this file and let's go to the app.component.ts file. And here I will add some basic code. We have to import these missing imports. Okay, so here it is saying that property input value has no initializer and is not definitely assigned in the constructor. So you have to either make it optional or give it a default value. Now we have the current value and previous value. So this also has the same problem. You have to make it optional, otherwise it will give you error in TypeScript. So now let's break it down. So on the top, we import the necessary symbols for Angular's core library, including onChanges and simple changes. We define an input property called input value using the input decorator. This allows the parent component to pass data to this component. Then we implement onChanges interface and provide the ngOnChanges method. Inside the ngOnChanges method, we receive the simple changes object that contains information about the changed properties. We log the changes to the console for debugging purpose, and then we check if the input property has changed by accessing it from the changes object. And then if input value has changed, we update the current value and previous value properties based on the current and previous values provided by simple changes. So now let's go to the template and let me add this. Okay, so finally in this template we display the current and previous values of the input value. So by implementing ngOnChanges, you can easily detect and respond to changes in the input properties. So let's quickly test it. So instead of using this app component, I am going to create a new component, move these changes to there so that we could use the app component as the parent component. So here I will add ngGenerate example. Okay, the component has been created. Now let's move all of this code there. So in the example.ts file, I have moved all of this code. Now let's move the implementation part as well. And let's remove the unused imports. So here, let me add the implementation part here. All right, now we need to again import the missing imports. So let's add all of the missing imports. Now from the HTML, let's move them here as well. Okay, so now it's time to use it in the app component. In order to use it, as we are using standalone component, so I will simply import it in the imports array example component. Okay, now you are able to use it. So here I will simply add app-example and it would be available immediately. So let's open the browser and here you can see current value and previous value is currently empty. Now here I will define a variable. So here I have added any random value, and here I will create a function generate random number, and we will update the input value with that random number. And now here I will add the button as well so that we could use it to generate the random number. We will add the click event and call the generate random function. And now let's pass the number into that child input value and input value. Okay, all right, now we are passing that, and here you can see it is saying that current value is this. But if you click on generate, then it will regenerate the current value and pass it to the child, and child will take care and show you the current and previous value. So previous value was 2323 and new value is 91. If you click on that again, then 91 would become the previous value and current value would become the 23 would be something else. So you can see, and it will keep happening in the same way. So let me show you again the logic. What we have, we did nothing. So now we react only if that specific input changes, otherwise we are not doing anything. So this is a good thing to have, that for example you have multiple inputs and you want to react on specific input change, so you can add it there and you can use the ngOnChanges and you can then react based on that specific change detection, or you can make an API call if you want to, if something is changed based on that. So by implementing ngOnChanges, you can easily detect and respond to the changes in input properties. This is particularly useful when you need to perform calculations, update the component state, or trigger certain actions based on the new values. Remember, ngOnChanges is called every time an input property changes, so it's important to keep the logic inside this method lightweight and efficient. So it's worth noting that ngOnChanges is available in all versions of Angular, including the latest version, Angular 17, so you can confidently use it in your projects. In summary, ngOnChanges is a powerful lifecycle hook that allows you to react changes in input properties. So by leveraging this hook, you can create more dynamic and responsive components that adapt to new data and provide a better user experience. Next up, let's explore on the most commonly used lifecycle hooks in Angular, ngOnInit. This hook is all about initializing your component and performing any necessary setup task. So the ngOnInit method is called once by Angular when the component is initialized. It's perfect place to execute any code that needs to run when the component is first created. So these are the common use cases for the ngOnInit. First one is fetching data from a server or service. Second one is initializing component properties. Third one is setting up subscriptions or event listeners. And finally, performing any other one-time setup tasks. So here is an example of how you can implement ngOnInit in your component to fetch data from a service. Let me quickly add the service as well so that we can get rid of these errors. Here I will generate s data, and then within that service let me first import it, and here I am giving it a default empty array. Now we need to define the get data function in the data service. So here I will add get data service, and now I can pass an observable of these arrays. So it can be any live API call from the internet as well, so it's totally up to you. So make sure to add the standalone component here. Okay, let me add the correct path of the file by adding the template URL, and let me add the HTML here. So I updated the payload of the subscribe function as well. So let me add the app. Make sure to add the common module here, otherwise you will not be able to use the for loop. Okay, we have the item coming from the service. So now let's break this down step by step. We imported the necessary symbols including ngOnInit from Angular's core library and a data service that we assume provides the data we want to fetch. Then we define a property called items to store the fetched data. Then in the constructor we injected an instance of data service using dependency injection. Then we implemented the onInit interface and provided the ngOnInit method. Inside the ngOnInit we call a helper method called fetch data to retrieve the data from the service. Then in the fetch data method we call the get data method of data service and subscribe to the returned observable. If the data is successfully fetched, we assign it to the items property. If an error occurs during the data fetching process, we log the error to the console, and in the template we use an ngFor directive to iterate over items array and display each item in an ordered list. By placing the data fetching logic inside the ngOnInit, we ensure that data is retrieved as soon as the component is initialized. So this is common pattern in Angular applications where components often rely on external data sources. Remember, ngOnInit is only called once during the component's lifecycle, so it's not suitable for the tasks that need to be repeated or triggered by specific events. As with the other lifecycle hooks we have discussed, ngOnInit is available in all versions of Angular, including Angular 17, so you can safely use it in your projects without any compatibility concerns. To sum it up, ngOnInit is go-to lifecycle hook for initializing your components, fetching data from services, and performing any necessary setup tasks. By leveraging ngOnInit, you can ensure that your components are properly initialized and ready to provide a smooth user experience. Let's move on to another interesting lifecycle hook called ngDoCheck. This hook allows you to perform custom change detection in your components. Angular has its own change detection mechanism that automatically detects changes in your component's properties and updates the view accordingly. However, there may be cases when you need more fine-grained control over the change detection process. That's where ngDoCheck comes in. So the ngDoCheck method is called by Angular during every change detection cycle, giving you the opportunity to implement your own change detection logic. This can be particularly useful when you need to detect changes in objects or arrays that Angular's default change detection might miss. So here is an example of how you can use ngDoCheck to detect changes in an object. Also, let me put the HTML here. So now let's go through this code step by step. We define an input property here called user of type the subject with the properties name and age. We also define a property called previous user to store the previous state of the user object. We implement the doCheck interface and provide the ngDoCheck method. Inside the ngDoCheck, we call a helper method called userHasChanged to check if the user object has changed. In the userHasChanged method, we compare the current user object with the previous object. If any of the properties name or age have changed, we consider the object has changed and return true. If the user object has changed, we log a message to the console and can perform any necessary actions or updates. In the ngOnInit method, we created a copy of initial user object and assign it to previous user. This ensures that we have a reference to the original state of the object. But make sure here in the ngOnInit method, we create a copy of the initial user object and assign it to the previous user. This ensures that we have a reference to the original state of the object. But make sure we have implemented the onInit as well. Okay, now you can add two lifecycle hooks in this way. So it's important to note that ngDoCheck is called frequently during the change detection cycle, so it's crucial to keep the logic inside this method lightweight and efficient. Avoid performing heavy computations or complex operations within ngDoCheck to prevent performance issues. ngDoCheck is available in all versions of Angular, including Angular 17, so you can safely use it in your projects. To summarize, ngDoCheck is a powerful lifecycle hook that allows you to perform custom change detections in your components. It's particularly useful when you need to detect changes in objects or arrays that Angular's default change detection might overlook. However, use it judiciously and be mindful of performance implications. Now let's explore two lifecycle hooks that are specifically related to content projection in Angular, which are ngAfterContentInit and ngAfterContentChecked. First, let's understand what the content projection is. In Angular, content projection allows you to pass content from a parent component to a child component using ngContentSelector. This enables you to create more flexible and reusable components. The ngAfterContentInit hook is called once after the first initialization of the component's projected content. It provides you with an opportunity to access and manipulate the projected content after it has been fully initialized. On the other hand, ngAfterContentChecked hook is called after every check of the component's projected content. It allows you to perform any necessary actions or updates based on the changes to the projected content. So for example, this is the code for the HTML, and let me update this code. Here we need to add the implements and let's import the missing imports. Okay, and then now let's go to the parent, but before that there is an error. Let's fix that. Okay, now in the app component we already are using the app-example, so within that I will pass a div with the projected content template variable. Within that I have added the h2 and p tags. Now let's reload it and go to the console to see the logs that we printed earlier. So let me first clear everything here, and now let's reload it. Okay, you can see first we got a console projected content checked, then we got the console projected content checked. Okay, so let's break down the code to understand it further. So in the example component, we use the ngContent to mark the place where the projected content will be inserted. Then we implemented the AfterContentInit and AfterContentChecked interfaces in the child component. We use the content child decorator to query and access the projected content with the template reference variable projected content. In the ngAfterContentInit hook, we log the initialized projected content and can perform any necessary initializations or manipulation. In the ngAfterContentChecked hook, we log a message indicating that the projected content has been checked. We can perform any necessary updates based on changes to the projected content here. In the parent component, that is app.component.html, we use the app-example selector to include the child component and pass the content to be projected using the projected content template reference variable. So if we look at this again, we have the projected content initialized and we also have the projected content. So if you hover on that, you will notice that the projected content, that is the DOM element, is highlighted in the browser. So it's important to note that ngAfterContentInit and ngAfterContentChecked are specific to the content projections and are not triggered for our regular component content. These hooks are available in all versions of Angular, including the latest Angular 17 release. In summary, ngAfterContentInit and ngAfterContentChecked are crucial lifecycle hooks when working with content projection in Angular. They allow you to access and manipulate the projected content after initialization and during change detection, respectively. By leveraging these hooks, you can create more dynamic and interactive components that rely on content projection. The final lifecycle hook we will cover in this tutorial is ngOnDestroy. This hook is crucial for cleaning up resources and preventing memory leaks in your Angular applications. The ngOnDestroy method is called when a component is about to be destroyed and removed from the DOM. It provides you with an opportunity to perform any necessary cleanup tasks before the component is destroyed. One of the most common use cases of ngOnDestroy is unsubscribing from observables. When you subscribe to an observable in a component, it's essential to unsubscribe from it when the component is destroyed to avoid memory leaks and potential performance issues. So let me prepare another example to show you here. So let me import the missing imports. Click on the add import and make it optional here. Alright, import the data service as well, and this is a deprecated method, so let me revert it in this way. And also let's replace the HTML for this. So now you can see that this is an example that demonstrates how to use ngOnDestroy to unsubscribe from an observable. Let's go through the code step by step. First, we import the necessary symbols including ngOnInit, ngOnDestroy, and subscription, and a data service that provides data through an observable. We define a property called items that has an empty array by default, and it will store the fetched data, and a private property, and then we also defined a private property subscription of type subscription. In the constructor, we injected an instance of data service using dependency injection. In the ngOnInit method, we subscribe to the observable returned by the data service.getData function and assign the subscription to the subscription property here. When the data is successfully fetched, we assign it to the items property. If an error occurs, we log it to the console like this. When the data is successfully fetched, in the ngOnDestroy method, we check if the subscription exists and call the unsubscribe method to unsubscribe from the observable. So by unsubscribing from the observable in the ngOnDestroy, we ensure that any ongoing subscriptions are terminated when the component is destroyed. This prevents memory leaks and potential performance issues that could arise from lingering subscriptions. It's important to note that ngOnDestroy is called only once, just before the component is destroyed. It's ideal place to perform any necessary cleanup tasks such as unsubscribing from the observables, cleaning timers, and releasing resources. The ngOnDestroy lifecycle hook is available in all versions of Angular, including the latest Angular 17 release. In summary, ngOnDestroy is a vital lifecycle hook for cleaning up resources and subscriptions in your Angular components. By properly utilizing ngOnDestroy, you can ensure that your application remains efficient, avoids memory leaks, and maintains optimal performance. Always remember to unsubscribe from the observables and perform any necessary cleanup tasks in ngOnDestroy to keep your Angular application running smoothly. Angular 17 introduces two exciting new lifecycle hooks that provide more fine-grained control over the rendering process. These are afterRender and afterNextRender. These hooks allow you to perform DOM operations and initialize third-party libraries after the component has been rendered. The afterRender hook is called immediately after the component's view and its child views have been rendered. It provides a way to execute once the initial rendering is completed. On the other hand, the afterNextRender hook is called after next rendering cycle, which occurs when there are any changes to the component's view or its child views. So let me quickly prepare the example for you to explain. Okay, and let's import all of the missing imports, and we have to make it optional. So this is just an example, just to give you an understanding, just to give you overview of it. it. So let's break down this code. We imported the necessary symbols including afterRender and afterNextRender. So this is the basic starter code to talk about. Let's break down the code. We import the necessary symbols including afterViewInit, afterRender and afterNextRender. We implemented afterViewInit function and gave it a method that will initialize the chart, and also we implemented the afterNextRender and gave it a callback function that will call the update chart. So this method will be called immediately after the initial render. Inside the initialize chart method, we retrieve the chart element using this viewChild element ref and initialize the cart library. Initialize the chart library using this element. So this can be any chart library. I am just giving you example that this is a type of that chart and you can use anyone. So we used the after next render function to define the update cart, to call the update cart method in its callback. This method will be called after the next rendering cycle. Inside the update cart method, we can perform any necessary updates to the cart based on the changes to components view or its child views. So right now I'm not going to use the chart, so I will just quickly show you example by showing the consoles. Okay, now let me show it in the console. Okay, and in the update card, let me show you another console. In the update chart, let me show you another console log with a different message update. Okay, now let me that as well. Hello world. Now let's go to the parent. Now let's reload it, and here you can see some console logs. So first, this is the console that we see chart is equal to this div, and this is the element reference that we can hover, and it will hover the highlight the area in the DOM. Then as soon as it is updated, it will be called again. So on every render this function would be called. So for example, let me demonstrate that. So let's say I have a counter property here 0 that would be updated after every 1 second, or after every let me add an interval, set interval, and let's add a delay of 1 second, and let's update the counter, and now I will print it in the HTML with that counter. Okay, now let me reload it and I will show you. I also made a mistake here. There should be after render instead of after next render. Okay, great. So now you can see that the counter is changing, and on every counter change it will print the console and it will give us the reference of that variable, and this is happening because of this function. So basically you can add the initial here and update cart here. Okay, now you can see that on initialization this would be printed only once, but this would be printed after 1 second, every 1 second, because this is in the after next render, and this would be repeated, and because this is in the, and this is being printed from the after render, and it would be keep updating after every second, because whenever this counter is changed it re-render your DOM. So you can add this thing here as well. Okay, so by utilizing the after render and after next render hooks, you can ensure that certain operations are performed at appropriate times after rendering. This is particularly useful when working with third-party libraries that need to be initialized or updated based on the rendered DOM. These hooks provide a cleaner and more structured way to handle post-rendering tasks compared to using set timeout or other workarounds. It's important to note that these hooks are specific to Angular 17 and are not available in earlier versions. If you are using Angular 17 or later, you can take advantage of these hooks to have more control over the rendering process and perform necessary operations after rendering. In summary, after render and after next render hooks introduced in Angular 17 provide a convenient way to execute code after components view has been rendered. They are particularly useful for initializing third-party libraries and perform DOM operations that depend on the rendered elements. By leveraging these hooks, you can write cleaner and more maintainable code for post-rendering tasks in your Angular application. Other than that, we have another feature called DestroyRef, which provides a more flexible way to handle component destruction and cleanup resources. With DestroyRef, you can register callbacks that will be invoked when a component is destroyed. The DestroyRef class allows you to create a reference to a component destruction event. You can use this reference to register callbacks that will be executed when the component is destroyed. So this is particularly useful for cleaning up resources such as unsubscribing from observables. So let me quickly prepare the example for you to talk about it. So alright, so this is an example code. So let's break it down to discuss about it. We imported the necessary symbols including component DestroyRef and ngOnInit from Angular's core library. We also import an observable called SomeObservable that we want to subscribe to. In the constructor, we injected an instance of DestroyRef using dependency injection. In the ngOnInit method, we subscribe to SomeObservable and assign the subscription to a variable called subscription. We use ngOnDestroy method to DestroyRef to register a callback that will be invoked when the component is destroyed. Inside the callback, we clean up the subscription by calling subscription.unsubscribe. This ensures that the subscription is properly disposed of when the component is destroyed. Let me practically make it functional so that it could make more sense to you. So here, let me actually use the service that we have in the data we created earlier. Private data service is equal to data service, and this data service get data subscribe, and let me pass an object here instead within the subscribe function. Okay, so let me add anything here, hello world. All right, so in the ngOnDestroy, just to have an evidence, I will add an alert component destroyed. Right now there is no alert because it is not destroyed yet. So now let's destroy it. So I will add the if condition here, and we will define a variable here. Let's just make it very simple. Save it. We have hello world, and here let me get rid of all of this initial code, and I will add is visible is equal to true, and I will create a function toggle, and here in the HTML I will add a button, click, and we will call the toggle function. Okay, now we will wrap this in the if condition. Okay, so this is the modern way to use the if condition in Angular 17. You can use this approach as well, or you can use the ngIf directive as well. So whenever this is true, it will show the element, you can see, but as soon as I click on the toggle, it will set the value is visible to false, and this component would be invisible. This would be destroyed. So as soon it would be destroyed, our function ngOnDestroy would be called. So let's try it. You can see component destroyed alert has been appeared because of this. So by using DestroyRef, we can centralize the cleanup logic and ensure that resources are properly released when the component is destroyed. This helps prevent memory leaks and improves the overall performance of the application. It's important to note that DestroyRef is available in the latest versions of Angular 17. If you are using an earlier versions of Angular, you need to use alternative approach, such as implementing the ngOnDestroy lifecycle hook and manually cleaning up resources. When using DestroyRef, it's good practice to destroy cleanup callbacks for any resources that need to be released upon component destruction. This includes unsubscribing from observables, clearing timers, releasing event listeners, and any other cleanup task specific to your component. In summary, the DestroyRef feature introduced in Angular 17 provides a convenient way to register callbacks for component destruction. By using DestroyRef, you can centralize the cleanup logic and ensure that resources are properly released when a component is destroyed. This helps prevent memory leaks and improves the overall performance of your Angular application. Now that we have covered the various lifecycle hooks in Angular, let's bring it all together with a practical demonstration. We will create a sample component and implement different lifecycle hooks to see them in action. So step 1 is let's create a new component called lifecycle example component. So to generate that component using Angular CLI, we will run the command ngGenerate component lifecycle-example. So let's open the terminal and run the command ngGenerate component lifecycle-example. Press enter. So in next step, we will implement lifecycle hooks. For that, open the lifecycle component.ts file and let's implement the desired lifecycle hooks such as onInit, onChanges, doCheck, afterContentInit, afterContentChecked, afterViewInit, afterViewChecked, and onDestroy. And we will add the log statements inside each lifecycle hook to track their invocations. So this is how I have implemented all of the lifecycle hooks, and we added the log in all of these. You can see the constructor. We have the constructor called in ngOnInit. We have ngOnInit called, ngOnChanges called, ngDoCheck called, ngAfterContentInit called, ngAfterContentChecked called, ngAfterViewInit called, ngAfterViewChecked called, ngOnDestroy called. Now let's open the component where we want to use it. So let's say I want to use it in the app.component. So here I will import it, lifecycle component. One thing, we have to make it standalone. Make sure this is, so by default it should be added. I just copied pasted the code, that's why it was missing. So if it is added, then you are able to add it in the imports array, and once you do that, you are able to add it in the parent component app lifecycle example in this way. Okay, now let's observe the lifecycle hook invocations. So run your server and open the browser console to view the logged messages. So let's try that. Let me save it. Made a quick mistake while copying pasting, so let me fix it. It is SCSS. Alright. Okay, now let's expand this console and see. So let's observe the order in which the lifecycle hooks are invoked. First the constructor was called, then ngOnInit was called, then ngDoCheck was called, then ngAfterContentInit called, then ngAfterContentChecked, then ngAfterViewInit, then ngAfterViewChecked, then ngDoCheck, and then ngAfterContentChecked, and finally ngAfterViewChecked was called. So as you can see that lifecycle hooks are invoked in a specific order. The constructor is called first, followed by ngOnChanges, ngOnInit, ngDoCheck, ngAfterContentInit, ngAfterContentChecked, ngAfterViewInit, and ngAfterViewChecked. It's important to note that some lifecycle hooks such as ngOnChanges and ngDoCheck may be called multiple times throughout the component's lifecycle depending on the changes detected. When the component is destroyed, either by removing it from the template or navigating away from the view, the ngOnDestroy hook will be invoked, allowing you to perform any necessary cleanup tasks. By implementing lifecycle hooks in a sample component and observing their invocations, you can gain a better understanding of how they work and when they are triggered. This hands-on experience will help you effectively utilize lifecycle hooks in your own Angular projects. So remember to refer to the latest Angular documentations for any updates or changes to the lifecycle hooks API. Let's discuss some of these mistakes and provide best practices to avoid them. Mistake number 1. Forgetting to unsubscribe from observables in ngOnDestroy. When you subscribe to the observables in a component, it's crucial to unsubscribe from them in ngOnDestroy hook to prevent memory leaks. Failing to unsubscribe can lead to unexpected behavior and performance issues, and there are some best practices. Always unsubscribe from observables in the ngOnDestroy hook. Use the take until operator in the combination with the subject to automatically unsubscribe when the component is destroyed. So let me prepare a quick example just to talk about it. Alright, so let me add the missing imports. Let me inject the service again. You can inject service in this way as well instead of using the constructor. That's also acceptable and working in Angular 17. So now let's use this data service .get data .pipe, and within that pipe I have passed the take until function, and I have created a subject that saved in the destroy private property, and I have passed it to the take until operator that was imported from the RxJS. Then on ngDestroy, we are using the next function on the destroy property, and we are calling the destroy.complete. So in this way, you can unsubscribe to it. Next mistake is modifying component state in ngAfterViewInit or ngAfterContentInit. Modifying component state in ngAfterViewInit or ngAfterContentInit can lead to unexpected behavior and infinite loops. These hooks are intended for accessing and manipulating view or content elements, not for modifying component properties. And here are some best practices to handle this mistake. First one is avoid modifying component state in ngAfterViewInit or ngAfterContentInit. If you need to modify component properties based on view or content elements, do it in the response to user interactions or other events. Next mistake number 3 is overusing ngDoCheck and impacting the performance. The ngDoCheck hook is called frequently during change detection cycles, and overusing it can significantly impact performance. Implementing expensive operations or complex logic in ngDoCheck can slow down your application. There are some best practices to handle this mistake. Use ngDoCheck sparingly and only when necessary. Implement lightweight and efficient logic in ngDoCheck to avoid performance bottlenecks. Consider alternative approaches such as using ngOnChanges or other lifecycle hooks when appropriate. Next mistake is performing side effects in constructors. Constructors should be used for dependency injection and simple initialization tasks. Performing side effects such as making HTTP requests or subscribing to observables in constructors can lead to unexpected behavior and testing difficulties. And these are the best practices to overcome this mistake. Use lifecycle hooks such as ngOnInit for performing side effects and complex initialization tasks. Keep constructors focused on dependency injection and simple property assignment. By following these best practices and being mindful of the common mistakes, you can effectively leverage lifecycle hooks in your Angular applications while avoiding potential pitfalls. Congratulations, you have made it to the end of this comprehensive tutorial on Angular lifecycle hooks. Let's take a moment to recap the main points we have covered. Throughout this tutorial, we explored the component lifecycle in Angular and learned about the key lifecycle stages. We discovered how lifecycle hooks allow us to tap into these stages and execute custom logic at specific points in the component's lifecycle. We delved into various lifecycle hooks including ngOnChanges, detecting and responding to the input property changes, performing ngOnInit, performing component initialization tasks, ngDoCheck, implementing custom change detection, and then ngAfterContentInit and ngAfterContentChecked, accessing and manipulating projected content. Then we talked about ngAfterViewInit and ngAfterViewChecked, accessing and manipulating view related elements. Then finally we talked about ngOnDestroy, cleaning up resources and subscriptions. We also explored the new lifecycle hooks introduced in Angular 17 such as afterRender and afterNextRender, which provide more fine-grained control over the rendering process, and DestroyRef, which offers a flexible way to register callbacks for component destruction. By understanding and utilizing these lifecycle hooks effectively, you can enhance your components and optimize performance and create more robust and efficient Angular applications. Now that you have a solid foundation in Angular lifecycle hooks, I encourage you to experiment with them in your own Angular projects. Start with the simple examples such as logging message or fetching data, and gradually expand to more complex scenarios as you become more comfortable. Remember, practice makes perfect, so the more you work with lifecycle hooks, the more intuitive they will become, and the better you will be able to leverage their power in your Angular development journey. If you want to dive deeper into Angular lifecycle hooks and explore more advanced topics, I highly recommend referring to the official documentation. It provides comprehensive explanations, examples, and best practices for working with lifecycle hooks effectively. You can find Angular documentation at angular.io/docs or angular.dev. It's a valuable resource that will guide you through the intricacies of Angular development and help you to stay up to date with the latest features and techniques. Additionally, there are many excellent blog posts and articles written by experienced Angular developers that offer insights, tips, and real-world examples related to lifecycle hooks. I encourage you to explore these resources to further expand your knowledge and learn from the experiences of others in Angular community. Remember, mastering Angular lifecycles hooks is a journey, and every step you take brings you closer to becoming a proficient Angular developer. Embrace the power of lifecycle hooks, experiment fearlessly, and don't hesitate to seek guidance and inspiration from the vibrant Angular community. Thank you for joining me on this tutorial. I hope you found it informative and valuable. If you have any questions or want to share your experience with Angular lifecycle hooks, please leave a comment below. Happy coding, and may your Angular components be efficient and well managed.